So something else you're probably already familiar with about functions is there's two major classes. So we have 2, 8, 14, 20, 26. If I write that, then you recognize that that's an arithmetic sequence, which means we're adding every time. Oop, if I can write the word sequence, there we go. And we say that this has a common difference. D equals 6, and it also has a first term, a sub 1 equals 2. So the common difference in the first term totally characterize an arithmetic sequence. All right, and then your other sort of main type of sequence, if I start the same way, 2, 8, what am I going to do? What am I going to do? Oh, it's 32, 128, 496, and so on. All right, so this is called a geometric sequence, as I'm sure you're aware. But I just want to make sure we all have the terminology correct. So we call this a common ratio. Is what you multiply by. Oops, if I can spell the word ratio. Common ratio is r equals 4, because I'm multiplying by 4 every time, and I still have a first term, a sub 1 equals 2. So again, with both geometric and arithmetic sequence, the entire sequence is determined by two numbers. So if I know the first term and the common difference, I know every number in the sequence. If I know the first term and the common ratio, and I know it's a geometric sequence, I know every term in the sequence. In fact, there's a formula that can tell you that. So for an arithmetic sequence, and these are formulas you probably have seen before, but you may have forgotten. A sub n is equal to a sub 1 plus n minus 1d. And then for a geometric sequence, and these are easy, you like play around with them, you can see how it works, how it gives you all these values if you knew the a sub 1 and the d. For a geometric sequence, you have a sub n equals a sub 1 r to the n minus 1. So they're both sort of characterized by this n minus 1. And you know that happens because if I have n things and I call the first one of them 1, then the last one is going to be n minus 1 because I didn't include 0. Yeah, so I'm going to add the d n minus 1 times. That, in a way, like the d and the r are the spaces in between. That's a better way to think of it. The d and the r are the spaces in between the terms, because it's what you're multiplying by or what you're adding. Therefore, there is one fewer d than the term that you're on. There's one fewer r than the term that you're on, because there's, you know, if I'm on the fifth term, there are 4 spaces. There are 5 terms. I added 4 times. So that's why the n minus 1 shows up in both of those formulas, and it's important, and it's going to come back on us multiple times in various ways. All right. So this enables you, to find things like, let's say you know the a of n, a sub n. So we say a sub n, by the way, not a of n, as I almost did, because, in the notation, this n down here is called a subscript. So we often call this a sub n. So we say a sub n, or sometimes just an, right? So if I have a sub 4, often I'll just say a4, right? So for that, so this is a4, is a sub 4. If I say a to the 4th, right? So that's a 4th. You just say it like that. And if I have 4a, I'll say it like that. So you got to keep those things straight. If we say a4, we mean a sub 4. If we say 4a, we mean 4 times a, right? Just a little bit of comparative terminology there. All right, so we say, let's say we have a geometric sequence, and we're going to say that a sub n is geometric, first of all. If we don't know the sequence is geometric or arithmetic, and by the way, sequences do not have to be arithmetic or geometric. The first one that I gave you was square root. All right, it's not arithmetic and it's not geometric. Infinitely many sequences are neither geometric nor arithmetic. But geometric ones we're going to be really interested in the geometric ones. So if a sub n is geometric, and let's say I say with a sub 1 equals 3 and r equals 2, I can say, what is the 10th term? And this would really be more of a pre-calculus question than a calculus question. So you should be able to, but I'm just reminding you of these formulas and how they work. So what I would write for this is I would say a sub 10 equals my a sub 1, which is 3, times my r, which is 2. We're going to go to the 9th power because it's n minus 1, right? So I have 3 times 2 to the 9th, which is, let's see, 2 to the 9th is 512. So I have 3 times 512, so that's going to be 1,536. There you go. All right, so that's what we can do with our formulas for, so these are called nth term formulas for arithmetic and geometric sequence. So these two are called nth term formulas because they give you the nth term. All right, so the next important thing we have with arithmetic and geometric sequence are summation formulas, and those are going to be especially important to us because here's the hint about sequences. We're not here to talk about sequences at all. We're not remotely interested in sequences. We are interested in sums because the integral that we do is really a sum. So we're going to talk a lot about different kinds of sums and what we can do with them. We're going to get super nifty stuff, but I just want to make sure we're super solid on these basics before we get into that.